I'm Anil Kumar, sharing with you few concepts about trigonometric ratios in right triangle. We'll discuss how to solve right triangle, Pythagorean theorem, primary trigonometric ratios, inverse trigonometric ratios. We'll see how to find side length, angle of measurement for any triangle, and we'll have two application questions. Now, part of learning is not to waste time. So it is important for you to note that here is a triangle. If you can find the height and the distance x of this triangle, in that case, you need not watch this video, right? Ultimately, we are only learning all this to solve that problem. And if you already know how to solve it, you may watch my second video, which is more on higher level. So now let's begin to understand how to solve a right triangle. Now when I say a right triangle, I really mean that it is a three-sided figure where one of the angle is 90 degrees. So it becomes a right triangle. As you know, sum of angles is 180 degrees, right? So in this particular triangle, we know angle B is equals to 90 degrees, and therefore it is a right triangle. So what is the sum of angle A and angle C? So when we write like this, you know, we are talking about angle A means this angle and angle C means that angle. Sum of 3 is always 180 degrees, so 2 will add up to 90 degrees, correct? So all 3 will make 180 degrees. So what you notice here is that all these angles are really acute angles, correct? So we'll also be solving acute angles. Now getting back to Pythagorean theorem, you must be familiar with Pythagorean theorem before taking up this video. Let me give you a gist of it. Let us say if we are given side AB as, let me write in general, side opposite to A will normally be referred as lowercase a, side opposite to B will be referred to as lowercase b, and this will be C. Now Pythagorean theorem states that sum of these two sides, I have purposely not given them A, B, C as normally written. Sum of these two squares, a square plus c square in this case, since c is the smaller leg, is equals to b square, which is the hypotenuse. So in this particular example, you can see that the longest side is b for me, which we call hypotenuse. So that is always the longest side. So in this particular figure, that is the relation. Let us take few examples just to get or rather review what we have already learned about right triangles. Okay, so we'll make few right triangles here. So let's sketch two of them. Okay. Now in these right triangles, if I give you two sides, you can always find the third side, correct? So what we are saying here is this is a right triangle. This one is also a right triangle. So if I say that this side is 13 centimeters and the other side is 12 centimeters, you can find the third side. And if I say that this one is, let's say, 5 centimeter and the other one is 4 centimeters, you can find the hypotenuse, correct? You may use the calculator to do the needful calculations. So you know the third side will be 4 square plus 5 square square root. Since that is the longest, you add these two legs, right? Now in this particular case, this is a smaller side, that is longer. So we just do 13 square minus 12 square, and then we do square root, right, to get the answer. So let's use the calculator to find these answers. So we have square root of 4 square plus 5 square, which is 6.4. So this side is 6.4. Units are same as centimeters, right? In centimeters. The other side here is one of the legs of this right triangle. That will be square root of 13 square. Take away 12 square. Now I want to emphasize here, which is 5 centimeters, that don't get into intricacies of A, B and C, right? Just forget about it. So basic thing is that the longest side or hypotenuse square is equals to leg 1 square plus leg 2 square. Do you understand? So sum of these two legs of a right triangle, square of these two, is equal to square of the third. I have found students wasting time in just figuring out what is A, what is B, and what is C. It does not have any significance. So I hope that point is absolutely clear. So with that short review on Pythagorean theorem, let's get to the major topic, which is understanding primary trigonometric ratios. Now, since I have used the word primary, there is another which is called secondary, right? So trigonometric ratios, these we'll cover in the next video. Secondary trigonometric ratios are basically reciprocal of primary, right? So 1 over primary will give us secondary. Okay. To begin with, it is kind of important to understand that if I have a big triangle and in between I divide it with parallel lines, let's say, so these lines are all parallel, in that case, we'll find that the ratio is constant. So in this case, what we'll find is that if these are my triangles and those are the dimensions, then what we will find here is that the ratio of 1.1 over 3 will be approximately equal to ratio of 1.8 over 5, right? The base length. Simple reason is they are similar triangles. Correct? Because this is 90 degrees and they have a common angle. And therefore, they are similar triangles. Correct? So basically, what we see here is that this angle plays a very critical role. We normally refer to these angles with Greek symbols like theta. So this what I made here will be many times used. It's a Greek symbol and we call it theta. You can always refer to angles as we did earlier with the vertex of a triangle, but in many cases we'll use these Greek symbols. So soon you'll learn about alpha, beta, gamma, and then this is theta, and then we have phi. So these are very, very popular. Alpha, like A, B, C, right? Alpha, beta, gamma, and phi. That one is theta, the most common of all. Now, well, let's verify if these ratios are same or not. I don't know. 1.1 divided by 3 is approximately equals to 0.366, and 1.8 divided by 5 is approximately equals to 0.36, right? So they're kind of similar. So I just, because I rounded them, so we find that this is 0.36, right? Till now, you were solving triangles using similar triangles also. So you could find what y is. Let me do that also. So you could find what y is. Y over 7, the bigger triangle, should be equal to this ratio. Let's say 0.36. Is it okay? So that means that y should be equals to 0.36 times 7, correct? So if I multiply 0.36 by 7, I get 2.5. So this dimension will be 2.5 for me. So in a way, we have solved a triangle by finding the sides, right? And this triangle could also be solved for angles since, well, not really. Since this angle theta is not known. Now, that is the difficulty, right? So trigonometry plays a big role, especially to find angles in any triangle. So that is a huge advantage. And therefore, we actually name these ratios with reference to angle. So the ratio which we just talked about is called tangent ratio, right? So that is called tan, written in short as tan theta, tan of angle theta. So this ratio which we are talking about is in terms of the angle in a triangle. We are only considering right triangles, in a right triangle, that is it okay? And we say that this ratio is equal to the length of that side is opposite to theta, right? So length of opposite side over, this is called adjacent side. Okay, so I hope this is clear. That is our first trigonometric ratio, tan ratio. Tan ratio is very significant as it also gives you slope, right? So let me write down here slope. That's a very practical application, rise over run, right? Which is rise over run. So many applications will look into rise over run. For example, of a ramp, you can use tan ratio. The other ratios will incorporate the hypotenuse. So we have two other ratios in primary ratios. One of them is called sine theta. So sine of angle, that angle, right? Theta. Sine theta is opposite over hypotenuse. So I'm just writing in short now. So it is opposite side length over hypotenuse. And we have the third ratio, which is called cosecant theta. In short, we'll write as cos theta, which is adjacent side over hypotenuse. Now these three are called the primary trigonometric ratios. So when we say primary trigonometric ratios, we mean tan theta, sine theta, and cosine theta, right? Always you should write them with lowercase, all a lowercase. Now let's take this opportunity to solve this and then we'll move forward. How do we find theta now? Now we already know that this ratio is given to us 1.1 over 3. So we say that tan theta is equal to, let us say, 1.1 over 3. Now to get theta, we'll kind of do inverse of this. You understand? We'll do inverse. Inverse is like reciprocal, correct? So we just the opposite operation. So what we do here is we take inverse at both the sides. So what we get here is angle theta is tan inverse of 1.1 over 3. So that is how you get your angle. Now in a calculator, you will find that we have sine theta, cos theta, and tan theta. Now to find tan theta, for example, tan theta is 1.1 over 3, we will say just calculate the ratio, which is 1.1 divided by 3. That's it. And you get a value which is equals to 0.36 rackery. Is that okay? So you get the value of tan theta, which is ratio of these, or you can say slope. To find theta, we have to use tan inverse, which on a calculator, if you press shift button and then the tan, you see the tan inverse, right? So it's like this. And if I do tan inverse of the answer which we have, which is 0.3666, we'll get angle. So angle which we got here is 20.136, something like this. And this angle is in degrees. Angle measurements are also done in radians, but we'll stick to degrees. So the inverse of this, which we are going to learn in more details in this video in the next slide, but that gives you an idea, right? So we can get angle by using the inverse of the trigonometric ratios. Is that clear to you? Right. Now, as an exercise, you could find the value of sine and cosine theta. Well, we'll use Pythagorean theorem to find the hypotenuse, and then we can find sine and cosine theta. So let's do it. So we will use the Pythagorean theorem to find this particular hypotenuse. For the smaller triangle, opposite side 1.1, adjacent being 3. So in this case, let me say that this place is O and that is A for us. We are trying to find what is OA. So you know OA is square root of this square plus that square, which is 1.1 square plus 3 square. Correct? And using the calculator, we can find square root of 1.1 square plus 3 square is equal to 3.19. I'm writing this as 2. So we are rounding to one decimal place. We are writing this as 3.2. Correct? So once you know the hypotenuse, you can calculate cos and sine. In this particular case, sine will be ratio of 1.1 and 3.2. And cos will be ratio of adjacent side, which is 3 to 3.2. So both are ratios to hypotenuse. Now since sine theta and cos theta, you see longest side in the denominator, you cannot have sine theta greater than 1, right? So it could be maximum 1, correct? That also when theta is 0. So if theta is 0, then hypotenuse will be along this side. And only then sine and cosine thetas, I mean sine will be 0 being opposite side, but cos theta could be 0, right? I mean 1. So what you notice here, since sine and cosine are smaller sides over hypotenuse, their value is less than 1. Is it okay? So maximum value is 1. So we'll also make a note here that sine and cosine ratios could have maximum of 1. So let me write down here a note. Maximum value of sine theta and cos theta is 1. Okay. So it is always less than 1. The absolute value, right, is always less than 1. So let me summarize what we have learned here. We have learned that there are 3 types of primary trigonometric ratios. These are tangent theta, sine theta, and cosine theta. Tan theta is defined in a right triangle as the ratio of side opposite to adjacent side. Sine theta is a ratio of opposite side to hypotenuse. And cosine theta is ratio of adjacent side to hypotenuse. Since sine and cosine, the denominator is the longest side, they cannot be greater than 1. Tan theta can be, since it is a ratio of 2 smaller sides, either one of them could be longer, correct? So the range of tan theta is all numbers. But for sine and cosine, the maximum could be 1, right? Now, tell me one thing, a question for you. If I increase the angle and then make a triangle which is shown by this green line, then what happens to the ratios? So now you have to figure out that if I do that tan theta increase in that case, what will be the value of tan theta? What will be the value of sine theta, and what will be the value of cosine theta? Which one of these will increase, which will decrease? That is what you have to figure out if I increase the angle. So if I increase the angle to phi, where phi is greater than theta, in that case, you have to tell me what you can do is, you can say, in that case, sine phi and sine theta, how are they related? Cos phi, cos theta, how are they related? And tan phi, tan theta, how are they related, right? So you have to figure out this. That is to say, you can use any of these symbols. Is it okay? How are they related? So that is the question for you to work on. So let's move on, where we are saying that phi is greater than theta. Is it okay? Right. So I just introduced you to inverse trigonometric ratios in the previous example, where we were trying to find the angle. Now here, we'll do it in more details. We have a triangle ABC whose sides are 5 centimeter and 7 centimeters as shown. We have to find the angle Y and angle X. How can you find these angles? With Pythagorean theorem, you can find the third side, but you cannot find angles. To find angles, we always use trigonometry. Okay. Now if I have to find angle Y, then angle Y is related to the two given sides in which fashion, right? So here, this side is opposite, right? And the other side is adjacent. What we learned earlier was that for sine is a ratio of opposite to hypotenuse. Cosine is a ratio of adjacent side to hypotenuse. And tan is a ratio of opposite to adjacent side. Now in this particular case, we are looking into opposite and adjacent side, so we'll go for tan ratio. Do you see that? So that is how we decide which ratio to use. Now, tan of y can be written as opposite over adjacent, right? So this is opposite side, so opposite, in short, adjacent side. Is it okay? Now the opposite side is given to us as 5 centimeters and the adjacent is 7 centimeters. That is what tan y is. To find the angle y, we actually do tan inverse on both sides. So we do tan inverse of this thing, which is tan y, and we also do tan inverse of the right side, which is 5 over 7. Does make sense? Tan inverse of tan is just y. Is it okay? So the angle, so we get angle y equals to tan inverse of 5 over 7. So I hope this concept is clear. Now this is the only example where I'm going to write tan inverse. It's kind of understood from now onwards. Inverse means inverse operations. It nullifies the effect of tan. So you're left with only the angle y. And so y is tan inverse of 5 over 7. So now you can use the calculator and say shift tan inverse 5 divided by 7 bracket close equals to 35.53. So we get an angle which is 35.53, and this is in degrees since I've set my calculator to degrees. So that is how you find an angle. You can always round this angle to, let's say, 1 decimal place. So we get 35.5 degrees approximately to 1 decimal place. Now since we have found angle y, we can actually find the other angle. So in such cases, it is easier to find, let's call this angle as z. So we'll say from here, angle z, measurement of angle z as sometimes we write, will be equals to 180 degrees, which is sum of all the three. Take away 90 degrees, which is that angle, and just now we found y as 35.5 degrees. So we get angle Z. So 180 minus 90 minus 35.5 equals to 54.5. So we get this as 54.5 degrees. Now in most of my videos from here onwards, we will actually just straight away do 90 minus this because that is 90. We need not even write minus 90. It all saves time. Initially it is kind of important to write it, but soon you'll get used to it, right? So we get angle Z as 54.5, and now it's easy for us to find angle X, correct? So we can now write angle X, measurement of angle X, is equal to 180 degrees, take away the measurement of angle Z, right? So that is 180 degrees take away 54.5 degrees. So it is 180 minus 54.5, and that is equals to 125.5 degrees. Do you see that? So we find finally the measurement of angle X as 125.5 to 1 decimal place. So I hope all these steps are absolutely clear. To solve the triangle, you may like to find the length of AC, which you can find using Pythagorean Theorem. We'll also learn in the next slide how to find using trigonometric ratios. But I hope here the concept of finding angle using inverse is clear. We'll take up more examples as we move forward. Now, let's take few examples. Now here we have three examples. We'll find side length. So what we are given in each is one of the sides and two angles. 90 degrees and the other one, right? So be clear about it. To solve any triangle, we should have three things known, right? So let's write it down. That's also an interesting question. We need three parameters, let me call, to solve a triangle, right? So three things known is 190 degrees, right? It is known to us. So we know this is 90 degrees, correct? We are not writing, but it is known. So two angles and a side is known to us. Is it okay? Now, obviously, you can find the third angle very easily. So the question here is not to find the third angle, it's just to find the side. However, let's write down the third angle also. So if I have to write this angle, I'm not going to use 180 minus this, that, but I'll do 90 minus 25. So it is 65. Is that okay? So these are complementary angles, correct? So 90 minus 30 will say this is 60 degrees. Is it okay? 90 minus 20 will say that is 70 degrees. Is that clear? Right. Now, let us see how to find side lengths. So we learned that sine ratio is ratio of opposite to hypotenuse. Cosine is adjacent to hypotenuse, and tan is opposite to adjacent. Initially, it is important to keep this in mind. SOHCAHTOA, right? SOHCAHTOA, that's what students call here. So sine is the ratio opposite to hypotenuse. Now let us see what are we given. We'll ignore the angle calculated. We'll only concentrate on what is given to us. This is given to us and that is given to us. Is that okay? Now, if I see with reference to angle given, what is this side? This side here is adjacent side. So the side which is between the 90 degrees and the angle is called the adjacent. Is that clear? Now, if the adjacent side is given, in that case, we could use either cosine or tan. They have a in it, adjacent side, correct? So if I use cos, so what is cos of 25 degrees? Now cos is adjacent over hypotenuse. Let me write this as hypotenuse. Is it okay? So we get 6.2 over, let's say, h for hypotenuse. That's what we get. Is it okay? Now it's simple. I can find height hypotenuse as ratio of 6.2 and cos of 25 degrees. Do you get the idea, right? Since cos is always less than 1, we are going to get a value which is more than 6.2. So that is another way of looking into how should we do it. Should we multiply or divide? Should we multiply or divide, right? That's always a question. 6.84 is the hypotenuse. Okay, let's find this side here is opposite side, right? So to use, we should use tan theta to find opposite side. So here we can say tan of 25 degrees is equals to opposite side, let's say opposite side over adjacent, which is 6.2. And so opposite side is equals to, so we get opposite side as 6.2 times tan of 25. Is that okay? These are degrees. So we get 6.2 times tan of 25, which is 2.89. So we'll just call it 2.9. We can round this to 6.8. Okay. So that is how we have solved this triangle with reference to sides. Angle was easy, 90 minus. So I hope the steps are clear. I like you to, I'll just give you initial steps. I like you to solve and find the answers, right? Now in this particular triangle, 30 was given to us, and that is the hypotenuse. So we are given hypotenuse. Since we are given hypotenuse, we should use sine or cosine. Now if I look at this side, it becomes opposite side. So now I could use sine. So I can write sine of 30 degrees is equal to opposite side over 10. And therefore, opposite side is 10 times sine 30. Is that okay? So opposite side equals to 10 times sine of 30 degrees. You get your answer. The other value can be easily calculated. Now this side is adjacent because it is closer to these two angles. It is called adjacent side. Adjacent and hypotenuse means cosine. So we get cos of 30 degrees is equal to adjacent side over 10, which is the hypotenuse. So the adjacent side is 10 times cos of 30 degrees. Use calculator to find the answer. Use calculator to find the answer. Okay, let's get back to the last one. Now, to find the height, what should we do? Well, if we are looking from 70 degrees, it is the opposite side, and that is adjacent. Opposite and adjacent means tan. Therefore, we'll write tan of 70 degrees equals to height h over 8 centimeters. H equals to 8 times tan of 70 degrees, right? It is that simple. So I hope you got all your answers. Here are my calculations. We'll round to one decimal place. 8 times tan of 70 degrees is equal to 21.97, right? So we'll round to one decimal place, which is 22.0, and the units are centimeters, correct? The other two here are 10 times sine 30 degrees, so which is equal to 5. So this is 5.0 units meters. The last one here is 10 times cos of 30 degrees, which is 8.66. So we'll say 8.7 to one decimal place, units in meters, correct? In the previous one, the units were meters. Let's use the units meters in the previous example. So I hope the steps are absolutely clear and you understand how do we find the side length of a triangle using the trigonometric primary ratios, correct? Let's move on and find angles now. How to find angles in right triangle, that is what we learn with 3 examples. The first triangle, we have to find angle P. In the second triangle, angle Q. and the third angle R. In the first triangle, we are given that two sides are equal. We are not saying how much the sides are, right? That is very interesting. So since we are not saying anything, let's say these sides are x, right? Let's say these sides are x. Now how do we find the angle using these sides? Let me also remind you of our trigonometric ratios. We're talking about three primary, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So always remember this, make a note, especially for your first exercise, which we're trying to do now. So in this particular case, if you look from P, then these two sides are which sides? This is opposite, right? And this is adjacent. If it is opposite and adjacent, you're going to use tan. Is that clear? So we decide on tan and we say tan P is equals to ratio opposite to adjacent, both are x, same side, so which is 1. Now if both are 1, it means what? Let's find P as taking inverse of tan. So tan inverse of 1 is how much? Let's use the calculator. So we have shift tan inverse of 1, and that gives you 45 degrees. Okay, let's write down 45 degrees. So if this is 45 degrees, we found P as 45, right? Then the other one should also be 45. Does it make sense? Well, it does, since if you add 45 degrees with 45 degrees and 90, you do get 180 degrees, so that is correct. Is it okay? So if we have right isosceles triangle, as you know, the angle should have been 45 degrees, and that is what we get. So we are right. Is it okay? Perfect. Let's move on to the next one. Now here we need to measure angle Q. What are we given? Now if you look at this side, which is adjacent side, since angle and 90 degrees, is that clear? And this one is the longest side, which is hypotenuse. So if you have ratio of adjacent and hypotenuse, you're looking at cosine, correct? So in this case, we will use cos of Q as equal to adjacent side, which is 3 meters, over hypotenuse, which is 5. And therefore, angle Q, we could write P, or we could write measurement of angle P, or similarly measurement of angle Q, as some will write, is equals to cos inverse of 3 over 5. Okay, so again use your calculator, shift cos key, which gives you cos inverse, and we want 3 divided by 5 equals to, it is 53.13. So we'll write this as 53 degrees for the time being. Okay, or you can write 0.1. So we get Q as 53.1. The other angle, of course, is 90 minus this. Is that clear? Now the last example for finding angle is right there. What are we given? We are given from this angle and 90 degrees, we are given adjacent side. So this side is adjacent, right? And the other side is opposite. Well, here we are given the third side as 10 centimeters also. Now, which should you use? Since we are talking about ratios, 8x and 7x is better, right? That's funny part, right? We are not using the exact side, we are using the other two. Okay, the idea is x will cancel, right? If you use 10 and 8x, you don't know what x is. So that's a key. So we know opposite and adjacent. That means what? If you know opposite and adjacent, we should again use tan. So in this case also, we are going to use tan. So we'll say tan R equals to opposite side is 7x over adjacent, which is 8x. See, x cancels. So we have 7 over 8. That's the beauty. So don't use the 10 centimeter side, otherwise you get wrong answer. Now, so the angle R will be equals to tan inverse of 7 over 8, which is shift tan inverse 7 divided by 8 bracket close equals to 41.18, approximately 41.2 degrees. Is it okay? So that is how you're going to find angle. Now for angle, let's make a note. How do we write angle measurements? The best way to write angle measurement is, let's say M for measurement, angle, and let's say theta in general. Is it okay? So that is the best way to write. However, we are going to just write theta in most of the cases, right? At the most, we'll write, say, angle A sometimes. Is it okay? So we are going to use these three different ways of finding angles or writing angles. Is that clear to you? In most of the books, it is kind of like this. So I hope that is absolutely clear. Now let's move forward and take up application questions. In this video, we have learned the basic concepts of trigonometric ratios. We call them primary trigonometric ratios. We have seen how to find length and also the angle using these ratios. Now I'll have two examples. This is the first one, and we'll see how they help us in real life situation. The first question here is, a ladder 12 feet tall is leaning against a wall at 70 degrees angle. So let's say we make a figure like this. Let's say we have a wall here, and that's the ground. And let's say the ladder is leaning at 70 degrees. So that is the ladder making an angle of 70 degrees, right? So a 12 feet tall, that means the length here is 12 feet of the ladder against the wall at an angle of 70 degrees. So 70 degrees angle with ground, let me write down, just be clear, right? So it could be there also. So I'm adding 70 degrees with the ground. Is that clear to you? Now we need to find how high up the wall does the ladder reach. That means this height we have to find. This is one thing. Second, how far from the wall is the front of the foot? So that means this side. So let's say this is x. So these are the two things which we have to calculate. Since the wall is always upright, we'll consider this to be a right triangle. So that is our assumption most of the time. Okay. Now in this particular case, what is given to us? We are given hypotenuse. Do you see that? Which is 12. Now the ratios which we learned are sine is, I'm always repeating this, very important, right? Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tan opposite over adjacent. Since the hypotenuse is given to us, we'll actually use sine or cosine. Now in the first case, if you want to find for example how far it is, this is adjacent, you'll use cosine. But if you want to find the height, which is opposite, so this side is opposite, correct? So if you want to work with the opposite side, then we have to use sine. Is that clear? Correct? So we say sine of 70 degrees is equal to opposite side, which is h, over hypotenuse, which is 12. Now cross multiply, so we get h equals to 12 sine 70 degrees. Some of you may have to review ratios and fractions to really work well with trigonometry. So we have 12 times sine of 70 degrees. That gives us 11.27. So we get height of 11.27. So let's round to 11.3, and the units are in feet. Is that clear? Now let us see how to find x. Now to find x, this is the adjacent side, right? So we now know it is the adjacent side. Since we are using hypotenuse and adjacent side, we could use cosine, right? So cosine c lowercase is 70 degrees, which is x over 12. So x will be equals to 12 times cos of 70 degrees. Is that okay? So let's calculate this, which is 12 times cos of 70. 4.10. So it is 4.10. Let's write 10. Okay. So that becomes 4.1 feet. So I hope it is absolutely clear. We get height equals to 11.3 feet and x, the distance, as 4.1 feet. Correct? Okay. Let's move on to the next example, which is Anil wants to find the height of the pine tree. From some distance away, he measures the angle of elevation to the top of the tree to be 55 degrees. Then he walks 20 meters towards the tree in the same direction and measures the angle of elevation at 60 degrees. What is the WHAT? Okay, so what is the height of the tree? How far from the tree was Anil? So let's say we have a tree here. Let's say we have a tree here. We're calling it a pine tree. Let's say make it like a Christmas tree. Okay. Now Anil is measuring the distance. He is some distance away. So from the top, angle of elevation is 55. Then he walks towards the tree and then again measures. Is it okay? So this. So what we are given here is that initially it was 55 degrees. When you walk about 20 meters, then the elevation increased to 60 degrees. We need to find height of this particular tree. That is part A. And part B is how far from the tree is Anil. That means we have to now find this distance x also, right? We know that he covered 20 meters. So that is the situation. So I hope with all the knowledge you got so far, you should be in a position to find this solution. Let's see how to do it. Now, in this particular case, we know this is a right triangle, and we also remember sine is ratio of opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. All height distance problem, tan is the key. Do you see that? Height and distance, tan is the key. So at times you may have series of height distance problems. Always use tan. Is it okay? So if you have height and distance, then that is the key for you for most of the time. Okay. Now this question becomes slightly tricky since we are given these two dimensions. Take it as a whole, that is to say, this is 20 plus x. Do you see that? Now it becomes a simpler problem. So we could use tan theta. So tan of 55 is what? Tan of 55 degrees will be h over big triangle, right? So h over 20 plus x. 20 plus x. Is that clear? So we are now considering the bigger triangle. So if you consider the bigger triangle, then the angle is 55 degrees. The distance is 20 plus x. Height is h. So from here, we can write h is 20 plus x times tan of 55 degrees. Now let's move to the smaller triangle. So in the smaller triangle, which is this one for us, angle is 60. So we can say tan of 60 degrees is equal to height over x. Or from here, we get height equals to x times tan of 60 degrees. So we get a relation for height, and these can be equated, and we can find x, and then we can find height. Is that clear? Correct? So let's do it. So we'll just equate these two. That is to say, from these two equations, we are substituting the value of h in here. So what we get here is that 20 plus x times tan of 55 degrees is equals to x times tan of 60 degrees. Now tan 60 degrees, tan 55 degrees are simple numbers. Correct? So what you can do is, you can actually calculate these, or We'll actually isolate x. So let's isolate x. So we can say 20 times tan of 55 when you open the bracket is equals to x times tan of 60 degrees. And this number will bring on the right side x of tan 55 degrees. Is it okay? Now you can take x common and we have tan of 60 degrees minus tan of 55 degrees. And on this side we have 20 times tan of 55 degrees. Okay. So you can find what x is. So let's use the space which we have left here purposely only for this calculation. We get x as equals to ratio of 20 times tan of 55 degrees, that is the outside angle, and this side 20, divided by difference of the two angles, tan of 60 degrees minus tan of 55 degrees. It's good to look at it from this angle. So what we get here is 20 times tan of 55 divided by tan difference of these two angles. Right? So let's calculate. So we have 20 times tan of 55, and now we'll divide this by the difference which of tan 60 minus tan 55. So I've already put them in brackets. Actually I missed one bracket. So let me rewrite. Tan 60, right, bracket close, minus tan of 55. Tan of 55, two brackets closed now. Is it okay? So what we get here as x is equals to 93.98. So let me just round it to 94 units, which is meters. So we get x as 94 meters. Perfect. Now since x is 94, you can find what h is using this formula. So we have h equals to 94 times tan of 60 degrees, right? So let's do it approximately. We already have that number. We'll multiply this by tan of 60 degrees and round it to whole number. We have 162.79, so I'm writing this as 163 meters. Is it okay? So that is how we can actually solve. So we get height of 163 meters and we found x, the distance, the closest distance as 94 meters, right? So farthest will be 94 plus 20. Okay. So I hope with this you understand how we could apply the trigonometric ratios to simplify or solve the triangles, correct? So let's get back to our first page where we had a question. So if you look at this question here, it is exactly same as what we did just now. Is it okay? It is exactly same as what we did. So if you use the method which we applied, you can find what x is. So x will be equals to 10 times tan of 40, right? 10 times tan of 40 degrees divided by difference of these two, right? So tan of 50 degrees minus tan of 40 degrees. Is that clear? And as once you find x, then you know what is height, correct? So height h will be equals to x times tan of 50, x times tan of 50 degrees. Is that clear? I'd like you to solve this question on yourself independently. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my video, that'll be great. Thank you and all the best.